Okay, good morning class. So today we're looking at financial maths, and by unanimous decision, the question, we said we must just carry on because this stuff is so easy. So we're going to look at the examples for exercise 5, and exercise 5 is on page. Exercise 5 on 74. Okay. So now we're going to look at future value annuities. Okay, I don't need this page anymore. Future value annuities that ends early. In regular payments of annuities, if regular payments of annuities are stopped before the money is required. So say for argument's sake you're saving for 28 years. Okay? Or for 30 years. You are saving 1,000 rand for 30 years. Okay? But you are at that point when the 30 years elapse, so it comes to an end of paying 1,000 rand, you realize but you don't need that money yet. Okay? You still have 4 years before you retire. For argument's sake. Okay. Then what you do is you can then decide to stop paying the 1,000 rand into the account. However, that money, that lump sum that is in the account will gain an interest for 4 years. You guys understand? So if you leave that money in the account for 6 months, it will earn an interest for 6 months. So what we do is we use the FE value formula for 30 years. We take that lump sum and then we multiply it by the interest factor using the compound interest formula. Okay. So let's see how they do it here. So obtain from annuity formula. Okay. Here. If regular payments of annuity are stopped before the money is required, the value obtained from the annuity formula is the total at the end of the last payment. This total will grow according to the compound growth formula until the time that the money is taken out of the account. Let's look at the first example. Example 1. Example 1 is on page? Sorry? 73. Example 1 is on page 73. Okay, so someone pays a monthly amount of 1,500 rand into annuity, earning an interest rate of 9% per annum compounded monthly for 30 years. Okay, they also use 30 years. At the end of 30 years, he stopped his monthly payments but leaves the money in the account for a further 2 years. Calculate how much he had in his account at the end of 32 years. So when we start by using the FE formula. What is the FE formula? X into 1 plus I to the exponent n minus 1 all over. People, why didn't I use the PV formula here? It's not a payment. Not a loan. Okay? It's an investment. So the investment is done for 30 years. Alright? So we have X, which is 1,500 rand into 1 plus I, 9%, so 0.09 over 12 to the exponent, 12 times 30 minus 1 all over I, which is 0.09 over 12. We got 1,500, sorry, into 1 plus 0.09 over 12 to the exponent 12 times 30 minus 1, let's close the bracket, over 0.09 over 12 gives you 2,746,000, 2,746,000 115 rand and the 23 cents. So that is what he has in the account after 30 years. Can you see that? But what happens? We now draw an interest for a further 2 years. So we use it A is equal to P into 1 plus I to the exponent, which is the principal now is 2,746,115,23 into 1 plus, the interest rate doesn't change, so 0,09 over 12 to the exponent, 12 times 2, as is these for 2 years. So that gives us answer into 1 plus 0,09 over 12 to the exponent 12 times 2. Give you 3,285,000. 3,285,000. 489, 41. You guys understand? Now, of course, there's another way I could have done it. What I could have done was, I could have done a straight formula, straight calculation. The future value or the total at the end is going to be 1,500 Rand into 1 plus 0,09 over 12 to the exponent 12 times 30 minus 1, and this is all over 0,09 over 12. So that's the future value for 30 years. Not so. But what then happens? It draws an interest of 1 plus 0,09 over 12 to the exponent 12 times 2 years. We're going to punch that whole thing in the calculator there. Open brackets 1 plus 0,09 over 12 to the exponent 12 times 2. Also gives you 3,285,489.41. So whichever method you use, you should get the right answer, provided you have made no error, no mistake. You guys understand? Is there any confusion? Okay. Look at example 2. Example 2 is on page 74. Okay. So here we are told that Tande opens a savings account and immediately deposits 1,000 Rand. Now you see, now Tande is catching on nonsense. Why? Must variate our form, must change our formula. Okay? So, immediately means to say we must add 1 to the end value. Not so. He pays immediately 1,000 Rand into the account. 1 month later and thereafter, monthly basis, she invests 1,000 Rand per month for a period of 3 years. 1 month after a final payment of 1,000 Rand, Tande increases the monthly payment to 2,500 and continues the monthly payment for a further 3 years. The interest rate during the 6-year period is 10% per annum compounded monthly. Calculate the calculate the future value of this investment at the end of the 6-year period. So let's deal with the first 3 years first. Okay. So what happens is future value is x into 1 plus I to the exponent n minus 1 all over I. So future value total is going to be, for the first 3 years, is going to be 1,000 Rand into 1 plus I. The interest rate is 10% compounded monthly, so 0.1 over 12 to the exponent, 12 times 3 plus 1. Why plus 1? Pays immediately. You see that, people? Then minus 1, and this is all over I, which is 0.1 over. So after this 3 years, something else happens. That changes. Can you see that, people? Which means to say, this does now no longer conform to what's happening in that part of the sun. Not so. So what we do is, the amount is lying in the account that we saved for 3 years, we now use that compound interest on it. Okay? Why? Because this money saved will gain an interest. For how many years? 3 years. Can you see that, people? Then what happens? Then I must not take this into account here. So it will be plus. Plus. That's a bit too low. Plus. Again the future value. Why? Because they depositing 2,500 Rand in the account. Can you see that? So it's going to be 2,500, again future value. 2,500 into 1 plus 0,1 over 12 to the exponent 12 times 3 minus 1, and this is all over 0,1 over 12. Will give me a future value of 1,000 Rand into 1 plus 0.1 over 12 to the exponent 12 times 3 plus 1 minus 1 all over 0.1 over 12. And that answer must be multiplied by, becomes your p-value for the compound formula, 1 plus 0,1 over 12. Calculate becoming slower. The exponent 36. Okay, plus. Again fraction 2,500 into 1 plus 0.1 over 12. The exponent. I don't know what. Okay, so what we do is we work it out per year. So it's going to give you 58,147 Rand. That answer plus. As you can see, the calculator's memory is not big enough. So it's 1 plus 0.1 over 12 to the exponent 12 times 3 minus 1. And this is all over 0.1 over 12. 162,061 Rand. 162,601 Rand and 64 cents. Is that correct? People, so with that you should be able to do exercise 5 on page 47. Enjoy the rest of your day. Good morning, class. The full lesson can be found in the description box below.